Alright, we're going to be talking more about functions and their graphs. Alright, evaluate the piecewise function at the given values of the independent variable. What this piecewise function says is you have two choices. Either your function equals 3 times your value plus 5, or your function equals 4 times your value plus 7. Okay, and the way you decide is if they give you a value that's less than 0, then you plug it into the top one. If they give you a value that's greater than or equal to 0, then you plug it into the bottom one. So what this says is find f of -2. Well, -2 is less than 0, so I use f of x equals 3x plus 5. So to find f of -2, I have 3 times -2 plus 5, which is -6 plus 5, which is -1. So f of -2 equals -1. To find f of 0, 0 is greater than or equal to 0, so I use f of x equals 4x plus 7. 4 times 0 plus 7 would be 0 plus 7 is 7. To find f of 3, I see where 3 falls, here or here. Well, 3 is greater than or equal to 0, so I use f of x equals 4x plus 7, which is 4 times 3 plus 7, which is 12 plus 7, which is 19. Okay? These are kind of like the directions on when do you use this and when do you use this. Alright, so if we do another one, we use the top one if they give you an x that's bigger than or equal to -3. So -3, -2, -1, 0, 1, dot, 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 dot. You use the bottom one if x is less than -3, like -4, -5, -6, dot, 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 dot. Okay, so to find g of 0, I decide what 0 is. Is it greater than or equal to -3, or is it less than -3? It's less than -3, so I use g of x equals -x plus 3, which gives me -0 plus 3, which gives me -3, which gives me -3. Okay? To find g of -6, I got to see which condition -6 meets. And -6 is less than -3, so again I'm using g of x equals -x plus 3. That's going to be negative a -6 plus 3, which is going to be a -3, which is going to be 3. And then to find g of -3, -3 is not greater than, but it is equal to -3, so I use g of x equals x plus 3, which equals -3 plus 3, which equals 0. And there you go. Okay. Give me just a second. Okay. Sorry about that. Alright. Evaluate this piecewise function at the given values of the independent variable. This one says if x does not equal 3, so if it equals -5, -4, -3, -2, -1, 0, 1, 2, 4, 5, 6. The only thing it can't be is 3. So if they give you anything but 3, you type it in or you plug it into the top. If they give you 3, then you plug it into the bottom. Oops. Alright, so this one says find h of 5. Well, 5 is not 3, so I use the top one. So I have 5 squared, h of 5 equals 5 squared minus 9 over 5 minus 3. You got 25 minus 9, which is 16 over 2, which is 8. To find h of 0, that's not 3. So I use the top one again. 0 squared minus 9 over 0 minus 3. That's negative 9 divided by negative 3, which will be positive 3. And if I find h of 3, I use the bottom one, which says I don't care what you plug in, you get 6. So h of 5 is 8, h of 0 is 3, and h of 3 is 6. There's no x in the bottom function to even plug in, so it doesn't matter what y or x is, y is going to be 6, and that's why it's a horizontal line. Okay? Alright, piecewise functions. It says, the cell phone company offers the following plan. $20 per month buys 60 minutes, and additional time costs 40 cents per minute. We can represent this plan mathematically by writing the total monthly cost C as a function of the number of calling minutes T. So, as long as you don't go over 60 minutes, the cost of your bill is going to be $20, just a straight horizontal line at $20. As long as you go up to 60 minutes. Okay, at 60 minutes, and we don't do anything on this side because negatives don't make any sense. So from 0 minutes to 60 minutes, your plan is going to cost you $20. After that, it's going to cost you an extra 40 cents for anything over 60 minutes. So that's why they have to put this t minus 60 there. And it says if t is greater than 60. Okay, because if, like, let's say that I gave you 120 minutes, you're not going to get charged 120 minutes times 40 because the first 60 are free. So you're only, that's why you have to subtract off the free 60 minutes to get the remaining time that you're going to get charged the 40 cents per minute for. Alright, so at any rate, there's my piecewise function. I hope you paid attention to how they wrote them because you're going to have to write your own here very shortly. Okay, one says find and interpret C of 30. 30 is between 0 and 60 minutes. So that's only going to cost me what? $20. 100 is more than 60 minutes, so I have to use this function because my time is bigger than 60. So I'd have to plug in C of 100 equals 20 plus 0.40 times 100 minus 60, which is going to give me 20 plus 0.40 times 40, which is going to give me 20 plus 0.40 times 40 is 16, which is going to give me $36. Okay? Easy breezy. Alright, it says evaluate the piecewise function at the given values of the independent variable. Hit pause, come back when you're ready. And hopefully you got 4. F of negative 2. Negative 2 is less than or equal to negative 1, so I have to use the bottom function. F of negative 2 is going to be a negative parentheses, negative 2 minus 2. That's going to be a negative times a negative 4, which is going to be positive 4. Alright, hit pause, come back when you're ready. And hopefully you got 30 over 13. They want me to find g of 5. Well, if x is negative 8, I use the top one. 5 is not negative 8, so I'm using this one, which says g of 5 equals 5 minus 1, which is 4. Okay. Where did I get 30 over 13? My bad. Answer should be 4. Sorry. I write myself to change that. Alright, your answer should be 4. You're finding g of 5, which... Oh, goober. So sorry. I'm like, why did I screw that up? I threw it up twice. Okay, g of 5, which is not negative 8. The only time you'd use the bottom is if they gave you negative 8. They did not, so I don't use the bottom when I use the top one. I'm sorry. So g of 5 would be 5 squared plus 5 over 5 plus 8. That's going to be 25 plus 5 is 30 over 13. There we go. Sorry. Alright, Evaluating a piecewise function. This is the graph of a piecewise function, okay? And it wants us to find the domain and the range of the piecewise function on the left. Okay, so for my domain, you're going from left to right. And I've got graph, 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 going from negative infinity. But right here, you have, at 1, you have an interesting phenomenon. If I'm reading left to right, I have to stop there. Now 1 is included on this one because it's filled in. Then I have to do a union, and I pick up at this line, and the 1 is not included. It starts at 1 again, but see how it's an open circle? So it would just start at 1 without including it and go to infinity. Your range goes from, this would be negative infinity, but it stops right here at 3. So it goes from negative infinity to 3, and it includes the 3 because that's filled in. Then we jump up to 4, and I don't know how to write that. I think you just write it like that. Union 4, because it won't go any higher than 4 forever and ever and ever. I think that's how you write it. I'm not really sure. All right. So this one wants us to graph the piecewise function defined by these two pieces of functions. Then find the domain and range of the piecewise function. Okay, you have a couple of choices. The easiest choice is if I'm going to graph f of x equals x plus 2 if x is less than or equal to 1. The easiest way is just to make a table of values, but make a table of values knowing the shape of what you're graphing. This is going to be a straight line, okay? So if I pick values of x and it says less than or equal to 1, so I'm going to pick 1 first, and if I pick f of 1, I get 1 plus 2, which is 3. So I'm going to graph 1, comma 3. 1, 3. And I'm going to fill it in because 1 is included. Now I'm going to pick something less than 1. Let's pick 0. That would be 0 plus 2, which would be 2. That ordered pair would be 0, 2. And we know that this is a line, so 2 points is all I need. That's going to be this piece in purple. Okay, it stops there. They don't want, yeah, this line technically goes on forever and ever and ever, but they don't want anything past 1. So they just want the line, basically, that goes from all the way over here, but it stops at 1. After 1, they want me to graph this piece, f of x equals 4. Oops, let me change colors here. Okay, so the second one they want me to do is they want me to graph f of x equals 4 if x is greater than 1. Again, this is a line, it's a horizontal line. You can pick values of greater than 1, like 2, but if there is no x here, so I don't care what you pick, you're going to get 4 every time. So 2 would be 4, and this one is not included because, or at 1, it is not included. Okay, if you plug in 1, you still get 4. But, so at 1 it's 4, but it's not included, yeah. And then, so if I graph 2, 4, 5, 4, and again I connect the dots, I know this is a line, but this one is not included. There's my piecewise function. My domain would be negative infinity to 1, square bracket, union, round bracket on 1 to infinity. My range would be negative infinity to 3, right? Union 4. And again, I got to check on how to write that. Math Excel will tell you, I'm sure. Alright, so let's try another one. They want me to graph, these are two lines. I know they're lines because they're linear, first degrees. If I graph f of x equals x plus 3 if x is less than negative 2, I can pick some values. I can pick negative 2. It would be negative 2 plus 3, which would be 1. So negative 2, 1 is going to have an open circle because it's not included. So negative 2, 1 gets an open circle. Pick something else less than negative 2. Let's pick negative 4. Negative 4 plus 3 would be negative 1. So that ordered pair would be negative 4, negative 1 would be right here. I know it's a line, so it's going to do this. Just remember that that's an open circle. It's not included. So now to graph f of x equals x minus 3 if x is greater than or equal to negative 2. I'm going to pick negative 2 and give it a closed circle this time. Negative 2 minus 3 is negative 5, so negative 2, negative 5 is going to get a closed circle. Then pick something bigger like f of negative, not bigger, not smaller, function. Let's do f of 1. That would be 1 minus 3, which would be negative 2. That ordered pair would be 1, negative 2. And that, we know is a line, would look like that. Okay? That's piecewise functions. Alright, now they're going to get a little more complicated because they're going to throw curves in, parabolas and things like that. Well, same thing. If I graph f of x equals 1/2 x squared, if x is less than 1, I'm going to pick 1 to start with, but it's going to be an open circle. That's going to be 1/2 times 1 squared, which is 1 squared is 1, times 1/2 is 1/2, so 1 comma 1/2. 1 comma 1/2, and that's going to be an open circle. Pick something less than 1, so let's do f of negative 1. That would be 1/2 times negative 1 squared. Negative 1 squared is 1, times 1/2 is 1/2. So again, we get negative 1 1/2. Negative 1 1/2. And then I know what shape it is. This is a parabola. It's just that I'm only drawing this half of it. So it's going to look like that. And you could pick more points to get it more accurate. I could have picked f of negative 2. Would be 1/2 times negative 2 squared. That's 4 times half of 4 would be 2. Negative 2, 2 would be right there. And again, we know it makes a parabola shape. Alright, so now to graph the 2x minus 1, which is a line. To graph f of x equals 2x minus 1 if x is greater than or equal to 1. We pick 1 first. 2 times 1 minus 1 would be 2 minus 1 is 2. 1, 2. That one's going to be filled in because of the bar. Now pick something bigger than 1. Let's pick 3. I'd have 2 times 3 minus 1. 6 minus 1 is 5. So 3, 5. And this is a line, so I connect like this. And there you go. There's your piecewise function. Alright, you do this one, hit pause, come back when you're ready. And hopefully you got D. If I graph f of x equals negative x plus 3 if x is less than 2, you pick 2 first. Negative 2 plus 3 is 1, so that's going to be 2, 1, open circle. So if I go to 2, 1, that's going to be an open circle, yeah. Pick something smaller than 2, so let's pick, I don't know, pick negative 1. I'd have negative 1 plus 3. That's going to be 1 plus 3, which is going to be 4, so I have negative 1 comma 4. Negative 1, 1, 2, 3, 4. And again, I know that this is a line, so if I connect those making a line, there's negative x plus 3 if x is less than 2. If I graph the other side, f of x equals 2x minus 3 if x is greater than or equal to 2. Pick 2 first, because that's the boundary. I get 2 times 2 minus 3. That's 4 minus 3 is 1. So 2, 1. Again, but this one is going to be filled in. And then pick something bigger than 2. Let's pick 4. So I'd have 2 times 4 minus 3 would be 8 minus 3, which would be 5, which gives me 4 comma 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And if I draw that line, I get that part of the function. We made a V. Alright, do this one. There's 3 of them, so don't worry about it. Hit pause, come back when you're ready. And hopefully you got C. Alright. We're graphing this top one. We got 2 limits on it. We've got negative 8 and 3, and we know that this is a line. So to pick this one, those are the 2 numbers I want to pick and make a line with. So if I pick f of negative 8, I get negative 8 plus 4, which is negative 4. That ordered pair is negative 8, negative 4. Which is right there, and it's filled in because of the bar right there. And then I pick 3, which is going to be an open circle because of the no bar. And that's going to be 3 plus 4, which is 7. So 3 comma 7 is right there, but I use an open circle. So there's the top. Okay, the middle says f of x equals negative 9 if x equals 3. So if I plug in 3, it doesn't matter what you plug in, I get negative 9. That ordered pair is 3, negative 9, and that's just a dot. Okay? Because they just gave me 1 point if x equals 3. Like if they would have given me between 3 and something, then it would have been a horizontal line between there. But if it's just 1 point, then that's just a dot. Alright, and then to graph my third one, oops. Sorry, hold on. To graph my third one, alright, I say f of x equals negative x plus 7 if x is greater than 3. So if I pick 3, I get negative 3 plus 7, which would be 4. So I get 3 common 4 with an open circle. Right there, open circle, and then pick something bigger than 3. So let's pick, I don't know, 5. I get negative 5 plus 7, which would be 2. So if I plot 5, 2, 5, 1, 2, we know it's a line. That would be this. And there's my 3 pieces of different functions. Okay? Alright, you try this one. Hit pause, come back when you're ready. And hopefully you got 1. Okay, they want you to find the range of y equals f of x. Well, they've already drawn it for me. Okay, so the lowest point that I have is 0. And the highest point that I have is a 6. The highest y value I have is a 6, but it's not included. So my range goes from include the 0, but not the 6. Okay, and notice that they graphed these. It said f of x equals 4 if x is between negative 6 and negative 3. So when I plug in negative 6, I get 4. And that one's filled in. When I plug in negative 3, I get 4, and that one's not filled in because there's no. So there's my f of x equals 4. Sorry, I'm trying to change colors. F of x equals the absolute value. Took my pen away. Hold on. Okay, so in blue I have f of x equals the absolute value of x from negative 3 to positive 6. At negative 3, if I plug in negative 3, I get 3, and it's included. If I plug in 6, the absolute value of 6 is 6, I get 6, it's not included, and I know that absolute value makes a V shape. Okay? And so they plugged in 1 in the middle and they got 0, because I know that absolute value makes a V. And then the cube root of x, okay, they plug in 6 and they got 1.8, and they plugged in 13 and got 2.4, and those are both included. And then this would be an S shape, but we're just connecting those two parts of it. Okay? Alright. Try this next one. Hit pause. Come back when you're ready. They want the domain. They're giving you the picture. And you should get this. Your domain goes the leftist x coordinate is -6, right? We've got a filled in circle and a gap here, so we've got to stop at -3. That's not included. Then this one is included if I describe this section, and it goes all the way to 6, but does not include the 6. And then it starts again at 6, which includes the 6, and goes to 13 and includes that, because those are both filled in. Okay? Alright, so how do you evaluate piecewise functions at given values? You choose correct piece of function to use based on your x and evaluate. How do you graph a piecewise function? You do each piece separate. Plug in boundaries and 1 or 2 more points to plot and graph. Alright, and we are at homework, so happy homeworking, and I will see you next time.